Hey everyone, thank you for being here at this unusual time for High Strangeness. So instead of our usual Saturday night time, it's a little early. I actually have natural light in here. I don't know. I don't know how to light for natural light. But
So I listened to your stream from last week where you were going over lots of stuff. You are on your way to seeing the reality of our world, and it's great that you have an open mind, but don't let your brain fall out with such an
no.
open mind. And I don't want anybody here that thinks flat Earth is stupid just to believe me. I want you to do the research yourself. I'm going to point towards lots of doors that you never knew were there, and then you can kind of figure it out yourself from there. Does that make
Awesome. Yeah,
sense?
yeah, no, and I am game for that. But before we get into it,
Yeah.
I'm curious to know because I had seen in because I've watched some of your interviews that you weren't always a flat earther, that you came to it kind of over time. But like what was your tipping point?
My tipping point was when I was forced to look into it, when I was told,
Mhm.
when I was just so tired of hearing it, I banned people from our social media. I was forced to look into it, and I went into it with a not an open mind like you are today, but I went
Mhm.
into it like I'm just going to prove the globe and disprove flat Earth, and that's how you become a flat earther because Globers say the same thing. Flat Earth is stupid because their idea of what a flat Earth is absolutely insane. And because it's not our idea, they Google flat Earth, they end up at the Flat Earth Society, which is a disinformation site to make flat Earth look really stupid. Okay, and then the other thing is they don't even know their own model. For example, you think, and I'm not picking on you. I'm just,
No, I know you in
I'm just
general. Yeah.
yeah.
Mhm.
I'm still screwing around with my setup here. Um, what the hell is going on? If I ask you how big, I mean, how fast is the Earth spinning? Do you know the answer? You've done a little research. I'm guessing you know the answer.
Oh, I mean, I don't know from my research, but I vaguely remember from when I was a kid. Is it 60 something miles per hour?
60 miles per hour. It's spinning at the equator at 1,000 miles per hour. That's
Thousand.
faster than the speed.
Yeah, I don't.
Yeah,
Okay.
that's faster than the speed of sound. So when you watch the sunset, you ever watch
Mhm.
the sunset, or you go to the beach,
Yeah.
nice and relaxing, watch the sunset? Do you believe that you're falling over backwards faster than the speed of sound on the top of a ball and you're falling over backwards, making the sun appear to go down when it's reality just moving away and getting lower due to perspective?
I've never given it much thought about,
That right.
I guess what you're
That
saying.
is yeah, that's the thing. Most people don't give it much thought at all. So when you watch the sun go away, it just goes away. It goes down lower and lower and lower, right?
Yeah. Mhm.
Due to perspective. But on a ball model, you have to believe that you're falling over backwards. Okay. So on top of that, do you know how fast it's orbiting the sun?
No. I mean, I've heard these numbers, but my brain doesn't remember numbers very well, as you
Well,
as you
but
just
here's the
saw.
thing: even when you um, hear the numbers, your brain doesn't calculate the numbers, right?
Hmm.
So in the heliocentric model, we're spinning at 1,000 miles an hour, which is crazy, right? Because if we're spinning on a ball, all of the water would go to the equator, right? Because it's spinning, right? The centrifugal force would send all the water to the equator, but that doesn't happen. And then we're orbiting the sun at 66,600 miles an hour. We're going around a year, right? And then we're chasing the sun because it's flying through the infinite space vacuum, which we'll have to get into, at a 500,000 miles per hour.
Hmm.
But none of these motions have ever been measured, observed in any way. They're just told to us,
Hmm.
right? And people believe that, right? So we're going all of these different speeds, flying through an infinite universe, right? Let's put that into perspective. Here's the hypersonic sled track. It's a rocket sled going on this train track. Ready? Here it comes. Did you see it?
It's
Did
gone.
you see it go by? It'll go again. That's
Yeah.
going by at Mach 6.8,
Okay.
6.8 times the speed of sound. You have to believe, if you believe in the heliocentric model, that we are orbiting the sun 10 times faster than that. We are chasing the sun at the same time 100 times faster than that. And
Hmm.
our entire galaxy is moving sideways at millions of miles per hour. Okay? And all of these motions aren't straight linear motions. They're all curved motions. Okay. I challenge you to go get in a car with somebody, find a beautifully straight, perfectly paved road and a really expensive car that has awesome suspension. Go 100 miles an hour, fill a dinner plate with water to the edge, and then have that person speed up, slow down, or take the slightest turn. What's going to happen?
Well, inertia will make it,
The
yeah.
water is going
Make
to
it,
go right out of the plate. Look at this lake. This is nature, right? Nature doesn't lie, right? This container, what do I mean by container? Water needs a container. If you didn't have a container, there's no water. If you go to take a bath and I get rid of the bathtub, what happens? The water's gone, right? If you go to a lake and I get rid of the side of the lake, what happens? The water's gone. Okay. Water needs lateral pressure to hold it. Okay.
Can I ask a question though?
Yeah, sure.
I don't mean to interrupt. I just want to jump in with this question.
No, interrupt anytime.
And by the way, I saw your interview with Professor Dave. Can I just say, so rude and obnoxious? So I am not jumping in like that. I just, have a genuine question.
No problem. Just since you brought him up, and most people that look into it, he is a paid shill, if you will, if that's a word. He has 2 million fake subs. None of them showed up at the live chat, and he is not a professor. He now is doing damage control, saying that he hires professors to answer the stuff for him, and he just repeats it on his popular YouTube channel. Total not nonsense. In the app, when we're done today, in the app, hit the web button, and then go to the Debunking the Debunkers and watch the first few videos, which are all about not Professor Dave.
Okay. Oh, that's interesting.
Yeah.
But he was hard to listen to because he was rude.
Horrible. You can only, if you don't have any facts, if you don't have any science, you can only be rude and obnoxious and talk in a way that makes people go, well, he sounds important. If I don't listen to him, maybe I'm stupid,
And that's how, and you know what? He's got that down, that type of professor impression down, because a lot of professors are like that. But so my question with that is, okay, so you were saying the example of a car, but a car has inertia because there's changes in motion and in movement. Even though we are supposedly moving that fast through the solar system and through the galaxy, it's constant. There's no change, big jerking, changing in that, in that motion. So you're not going to have inertia acting on the lake or the water. So wouldn't that be the case?
Incorrect. We're orbiting around the sun and we speed up and slow down. When we go close to the sun during our northern winter, closer to the sun during our winter, we're going faster and taking a tighter turn. And then when we shoot away, it slows down and goes back. When we're spinning on the Earth, when we spin, right, this line, if I'm going this way, this line should go that way, but it's not. It's going down, right? There is change of motion. We're dropping at the rate of drop at 1,000 miles per hour. If you're in an airplane, just to maintain your curve over the Earth, you have to drop like a mile a minute. A mile every 2 minutes if you're on an airplane. But if you're spinning, if you're flying at 1,000 miles per hour, like the speed of the Earth at the equator, you have to drop like over a mile a minute just to follow the curve of the Earth. That's pretty darn fast drop. Don't you think you'd notice falling at a mile a minute? And changing in your trajectory is acceleration, even though you're going the same speed, right? Just a slight change in your trajectory is defined as acceleration.
Okay. Gotcha. Right. Thank you for explaining that.
No problem. So let's just start. There's so many different ways to go. Where do you want to start? Like, what is the number one reason that you believe that we live on a globe? And then we could address that. But just first understand the difference between belief and knowing. Okay. Where do I live?
Where do you live? You live in Connecticut. That's what you told me.
Okay.
Right.
Okay. Is that a belief or do you know it?
It's a belief because I've never visited you in Connecticut.
Right. Is it easy? What's easier, to have a belief or to take the time and the effort to research where I live? Check out Facebook, find my friends, see that they're all in Connecticut. Oh, I found his high school yearbook and he lives in Connecticut. What's easier, belief or knowing?
Oh, totally. Just believing it.
Belief is easy. All you have to do is listen and go, okay. And then it's time to do whatever you want to do. Take a nap, smoke a joint, we'll go watch a movie. It's over. So people are generally looking for the laziest way to get something done. And you and I look at each other. You seem believable. You say you live not too far from me. I believe you. Do I know it? I believe it. I'm not going to research it. I'd rather just go with that belief. But people believe they live on a ball. But when you ask them, can you give me one reason? They can't. So they think they can. They go, well, what about day and night? What about time zones? What about ships over the horizon? What about, season? So any question you have, let's dive into that first.
Sure, yeah. And I mean, it's interesting because I understand what you're saying about, the pilots and dropping in the planes. But my dad was a military pilot, and he says he has, nothing honestly, he's saying that. I know he has no reason to, be confidential about it, that he's never seen anything that's convinced him, that
what would he see? I mean, he was a military pilot, you said?
Yeah, in the Marines.
Did you ask him when he's flying in a jet how fast, how much he has to push the what is it called, the null or whatever it's called, push the nose down to follow the curve of the Earth? Because if he doesn't, he's going to end up in space. A jetliner, if it doesn't nose down, is going to be 80,000 feet in an hour. That's a little bit higher than they think they want to fly.
So right? You're saying that when pilots fly, they're constantly intentionally nosing down?
No, I'm saying they're not, because the Earth is flat. If it was a sphere, they'd have to intentionally nose down.
Gotcha.
And there's many documents, FAA documents, NASA documents, not that we can believe anything from NASA, all sorts of documents that talk about the Earth as a flat, for all of their testing, that they treat the Earth as a flat, non-rotating plane. A flat, non-rotating plane for all of their testing, all of their manuals, all of their, mechanics. They look at the Earth as a flat, non-rotating plane. Now, the Globers will say, well, it's because the Earth is so big, it appears flat, so it doesn't matter. Nonsense. The curvature is way more than you would believe. And one of the things is we can see too far. A 6-foot-tall person standing at the edge of calm water, according to the size of the Earth that they tell us, would have a 6-foot drop in curvature at just 3 miles. So at 6 feet, the curvature drops 6 feet. So I would see a horizon, a physical horizon, and I would not be able to see the surface of that water past 3 miles. But you and I both know we can see much farther than that, right? We can see things that are, I can look across Long Island Sound here, 5 to 7 miles. I could sit on the edge of the beach and I could see people sitting on the beach there. There should be dozens of feet of curvature.
But the Earth isn't perfectly round. It has its flat parts. It has its.
It does. It has
that's
flat
what
parts. So if we have a flat part, when does it make up for the rest of that curvature? Does it get steeper after the flat part?
I don't know. And here's the thing, like you said, like it's all belief. Of course,
100%.
I don't have evidence of the round Earth, but I don't have evidence of flat Earth either.
I do.
And I think that. Yeah, I mean,
I have evidence that the Earth isn't round. Okay. Now, do I know the construct of the Earth? Flat is not a shape. Flat is a description of horizontal and level. Here's the Suez Canal. It's over 100 miles long. There should be over a mile of curvature, but there's no curvature. They didn't calculate for any curvature. There is no curvature, and we can see too far. If something went away from you, it would go behind the physical curve. Zooming in on it would not bring it back because you have a physical curve. But our horizon, horizontal, is an optical thing. For one thing, this is Skunk Bay. This is a time lapse. There's no tide here, but watch the shoreline. It disappears, and the buildings will actually disappear. This is just atmospheric conditions that will hide almost all of us. Look, it's almost all gone. This is a time lapse. So if you went there when it was up and you looked and you're like, oh, that's because of the curvature of the Earth. But then no one stays there long enough to go, oh, well, it's different today. That shows you that it's an optical thing that we're seeing. So
yeah, like some days we can see across the Sound and some days we can't.
Right, because of
Mhm.
visibility. Here is a camera 1 foot off the ground. Now, according to globe math, the horizon should be 1.2 miles away. Well, let's say 2 miles away. We shouldn't be able to see the surface of the water 2 miles away. This rig at 9.4 miles away, there should be 59 feet of curvature at that distance. But not only can we see the rig, we can see the surface of the water for dozens of miles beyond it. Okay? That's impossible on a ball. That's
Mhm.
impossible. We can see too far. People go, well, I've seen boats go over the horizon. When you look into the distance, clouds over your head are 5, 10,000 feet, whatever they are. But then I look down at New York City, and the clouds are literally touching the water. Now, are they really touching the water, Hash?
No.
But they look like they're touching the water because of
Yeah.
perspective. It all comes together. And when they merge with the water, are they really merging with the water? No.
No, just looks it.
It just merges into
Mhm.
a straight line, which we call a horizon. But if I can zoom in, what happens? I can zoom in on, so the ground is here, the sky is here. If I zoom in, I can increase this angular size and
Mhm.
make it bigger. And then I can zoom out farther and see again. So let's look at an example of that. So here we have a horizon, nothing's here. And I zoom in, and as I zoom in, I'm making the horizon bigger. And look, there's a boat there. Okay. Now watch these little waves in the foreground. These little waves in the foreground can block the boat. Like my finger is like a little wave in the foreground. It could hide the boat, and the boat disappears from the bottom up because it's getting smaller. But these little waves in the foreground are hiding it, and it's all merging with the horizon, just like these clouds are merging with the horizon. Okay. Now a glober would say that's over the horizon, and then you'd say, well, I just zoomed in on it. And then they go, well, refraction, it's refracting. And then they go, well, it's not refraction. It's because it's not that far away. You don't know how far away that boat is. Do you have the GPS coordinates? Where did you measure? Right. That's why I use the oil rig, because that we know exactly how far that is.
But how do
And
we
we
know
now,
it's not refraction, though?
because I'm zooming in on, well, first it disappears. That's a good question. There's the famous shot across Lake Michigan. Joshua Nowicki took it of Chicago, the Chicago skyline over 50 miles away. And the amount of curvature there should be hiding the tallest buildings. Okay, but we can see the whole thing. So that on the news, the guy goes, it's a mirage. He goes, it's because of refraction and this and that. So if it was refracting, there's a mirage. Well, you shouldn't be able to. We had a couple of our guys, they got on a boat, clear day, there it is. They zoomed in on the camera, and then they took off and they went 50 miles across the lake. And it never disappeared. If it was a mirage, refraction, it would disappear at some point. And as I showed you with Skunk Bay, the different weather conditions change it all the time. Well, someone else did a time lapse over 24 hours of Chicago, and none of the buildings got taller, smaller, they just stayed there with all different conditions, different temperatures, different lighting, different humidity. 24 hours, it never moved. It never moved. Right?
Okay.
You with me?
Yes, I'm with you. I'm taking this all in.
Yeah, so look at this example here. I have a matchbox on this table, and as I zoom in, oh, there it is. You can see it right there. But it's merged into the horizon. And as I zoom out, you can't even see it because it disappears. But it's there. So that's an example of things merging into the horizon. Then when you add atmospheric density, right? Atmospheric density makes it so you can't see that far. Like if you were in a swimming pool, beautifully clear water, and the swimming pool was 100 yards long. I'm at one end and you're at the other end. We go underwater. Could you see me? I mean, maybe not. Probably not. The water just becomes too opaque. So do you see me right now, or do you see the light that's bouncing off of me?
I see the light bouncing off you.
Of course, if I turned off all the lights and it was pitch black in here, you wouldn't see me. So the light that's bouncing off of me is not as bright as the light that is actually lighting me. Okay. So when we look into the distance, we don't see, if all the lights are off at night and there's no moon and no sun, you don't see anything, even though the things are still there. So here's a spot in Illusion, France. We're looking at 175 miles away. Mount Canigou should be out here, but it's not, because at this distance from that altitude, using globe math, the top of Mount Canigou should be over half a mile below the curve, below the Earth's horizon. So you believe this is the horizon. The light that's bouncing off Mount Canigou is not strong enough to push through all of the thickest atmosphere. When you're looking across the Earth plane, the atmosphere is the thickest. Rather than looking up, it's thinner. Okay? But twice a year, the sun migrates between the two tropics, and twice a year, it lines up with that viewing spot and Mount Canigou. And as it does, the sun moves away. All of a sudden, the sun, the brighter light that can push through, starts backlighting this mountain. And all of a sudden, you can see at the very top of the mountain here should be it should be over a half a mile below the curve. I think it's about a mile, but I'm not sure. But I round down. I always give the globe the advantage because flat Earth doesn't need it. There's so much extra room. It's unbelievable. Here's Mount Canigou. You have to believe that the sun and the mountain are already well below the curvature, and they're refracting up, stopping magically at eye level and not moving. That's what you have to believe. Mm-hmm. That's a leap of faith farther than I'm willing to take.
Mm-hmm. I mean, it's interesting because, like, while I'm still kind of struggling to not be skeptical still over it, and I appreciate the evidence you're giving me, I do feel like that a lot of things don't add up. I totally agree with you, on that point. Like, we're not being told something. Things don't make sense. Like, I'm totally with you on that. I sometimes just wonder, maybe it's for a different reason that things aren't adding up and things aren't making sense. But not to change the subject entirely to something slightly different, but I just want to touch on this a moment. Why would it matter, the fact that, whether we live on a globe or flat Earth, like, past the point, does it make a difference? And I know you believe it does, but I was wondering why.
So that's my favorite question. Mm-hmm. But giving you a gory example, if you walked into a room and there was 10 dead bodies on the floor, brutally murdered, sorry for this, is the best example I can come up with. Mm-hmm. And you walk in there, do you go, well, what's the motive? Why would anybody do this? Mm-hmm. You'd want to look at the evidence first. So let's look at a little more evidence, and then let's hit the why, because the why, to me, is the best evidence. Mm-hmm. Okay? But we'll get into that in a short while. Is that okay?
Sure. Yes. Yeah, that's fine.
All right. So let's use some math, easy math, and let's use our brains and not, the God-given common sense that we have, and talk about distances, right? So in the globe model, the Earth is tiny next to the sun, right? If the sun was a yoga ball, right, one of those big yoga balls,
yeah,
how big would the Earth be?
Oh, the Earth would be
like a BB or a marble.
Small,
yeah, a marble. Yeah, okay. A marble. Actually, a small marble. Okay, and so imagine if it's 12 noon, which means the sun is directly above you, and I move the sun just a mile above you. Would the sun fill your entire sky?
Yeah,
of course, right? And now I move it 93 million miles away. It's now the size that we see it, the size of like a nickel held at arm's length, right? Mm-hmm. So that's 93 million miles. That's where they tell us it is. They tell us that, but they don't tell us how they figured that out. And they keep changing that. If I doubled that distance, how much smaller would it get? Remember, it went from the entire sky, horizon to horizon, to the size of a coin at arm's length. How much smaller would it get?
Oh, gosh. So right? If you doubled it, yeah, a lot.
It would get a lot smaller. How about this? If I doubled it again, so now it's 4 times farther, do you think you could see it?
No.
Its angular size is getting smaller and smaller. That's a light half hour.
Mm-hmm.
Okay, if I doubled it again, now it's 8 times farther. That's a light hour. 1 light hour. You know what a light hour is? The distance light travels in an hour, theoretically.
No.
Okay. So at a light hour away, you and I agree it's scientifically provable that the angular size of the sun is too small for your eye to see. Well, can we move the sun 8 times farther? No, we can't. So how are we going to prove this? Well, NASA tells us Polaris, our North Star, which we can see with our naked eye, is 48 times bigger than our sun. So an equivalent distance where we could not see Polaris would be 48 times farther. So 48 times 1 hour is 2 light days. At 2 light days away, Polaris is scientifically provably not visible to the human eye. Would you agree with that?
Yes.
Do you know how far they tell us Polaris is?
Um,
433 light years away.
mhm.
Okay, 433 light years away. Now, there's also another problem that goes with that. We can't see it. Its angular size is wrong. But as a light source gets farther and farther away, its brightness diminishes exponentially. Every time you double the distance to a light, it's a quarter of the brightness. A simple experiment you can do is get a small little box, put a LED light in there, and then measure the brightness of the wall with the light meter. And then put it in a box, maybe foot wide, 2 feet wide, and then measure the lightness on the wall, and it's exponentially less. And then go in a dark room and hold that light in the middle of the room and measure the light on the wall. You might not even get a measurement because it's so weak. Because when light expands, it's taking the same light and it's stretching it. Like when you blow up a balloon, it's stretching the rubber and rubber. If I blew up a balloon to a mile wide, would there be any rubber left?
No.
And
Right.
it's
I
the
mean, it would
same
be.
thing with light. So the distances, the light issue is another distance, is another issue. It's called the inverse square law of light. It doesn't work. For us to see the moon at the brightness that we see it, at 100 miles away, where NASA supposedly took a beautiful picture of the moon, it would be 60 plus times brighter than we see the sun from Earth for us to see it at the brightness that we see it here on Earth. Because when you get to the moon, it should be so bright in order for us to see it the brightness that we see it. Does any of this make any sense?
It does, but I want to jump back to the star thing for a moment.
Sure.
But but when we talk about stars in our galaxy, we're talking about some massive sizes. I mean, the sun is tiny compared to those stars, and a lot of these, with way huge, huger, not that huge is a word, brightnesses. I mean, could that account for seeing these stars, from far away? The fact that we're looking at stars that are so much bigger and so much brighter than our own sun.
The moon on a full moon night. Let's go over this again. On a full moon night, you can read by the moon. It casts your shadow on the ground, right?
Yes. Yeah.
You know what I'm saying?
Yeah. No. Yeah. I'm trying to think about it. I think I phrased my question wrong, but.
Well, let me just go. So if I went halfway to the moon, it's 4 times brighter. Halfway from there, it's 16, halfway 64. And by the time I get to 100 miles from the moon, it's over 60 times brighter than we would see the sun. Could you imagine the sun twice as bright as it is? No one's ever seen something that bright. Mm-hmm. But for the sizes and brightnesses of the stars that would be absolutely ridiculous. Now, you just said that these stars are bigger and brighter because much bigger than our sun. Well, they tell us Polaris is 48 times bigger. Okay, let's go with what they tell us. Well, to compare it to the sun, we'd have to make it 48 times farther. We just proved that the sun at a light hour away is not visible. Forget the brightness issue because it would have to be so bright. And Polaris at 2 light days away is not visible. You're still going with, well, the things are bigger. I just showed you that the sizes they tell us don't work at 2 light days away, let alone 433 light years away. And now science is saying, well, Polaris might be 100 light years closer than we ever thought. That's a big problem. Yeah. But it doesn't matter. Make it a light week away. Can't see it. It's 300 or 433 light years away. So that there shows you that they're lying. The other thing is, we live on a rock covered in water, covered in air, adjacent to a void, a vacuum space. There is no experiment anyone can do anywhere under any conditions where you could have high pressure adjacent to low pressure, let alone a void, without a physical container.
Mm-hmm. I mean, okay. Yeah, no, I understand what you're saying. I mean, but on Earth, we do have high pressure systems and low pressure systems adjacent to
And what happens when you have high pressure and low pressure? Whoosh, you get wind. They equalize. If you had a room, if you were in a room and there was a room above you that was a vacuum chamber and there was a valve and a hose coming into your room and you opened it, what would happen?
It would, yeah, it would.
Equalize instantly.
Mm-hmm.
It would suck the air up and away from the ground, and it would go equalized instantly. Mm-hmm. Okay. How come the vacuum of space doesn't pull it away? Because the vacuum room above you just pulled air up and away from Earth at the closest point to Earth where the gravity is supposedly stronger.
Yeah. Oh, but putting gravity aside, what about our electromagnetic fields? Could that have anything to do with, could that act as a type of container for the Earth?
Nowhere in any experiment everywhere has anyone ever been able to show us that that can happen. But the only forces here on Earth, the only real forces are electromagnetism, electricity and magnetism. Those are the only forces. Now, there is a thing called the electrostatic force. And that is a testable, measurable, scientifically provable thing. So our world is set up like this, where this is how I see it. The sun and the moon are the cathode and the anode. The salt water carries the current, and the land is a salt bridge. It's a giant battery, okay? The Earth doesn't move. The Earth has a negative charge, testable, measurable, scientifically provable negative charge. Not a theory, it's actual fact. And the air, the sky, is a positive charge. So when you lift something up off the ground, it's now surrounded by that positive charge. So negative and positive attract. And it says, hey, down is this way. Well, that's a weak force, but guess what's a weaker force? The theory of gravity, which they have to make up dark matter, 90+% of it to make it work. No one's ever seen it, but like, hey, our theory is not working. Oh, let's make up some dark matter and dark energy crap to make our theory work. That's not science. Science is, you got a theory, it doesn't work, throw it out. Don't make up crap to make it work. But they say, globe science says the electrostatic force is 10 to the some number power stronger than gravity. Well, if I drop something that's more dense than the air, something is telling it to go down. Let's pretend it could be gravity and it could be the electrostatic force. How do you know which one it is? The electrostatic force is testable. The gravitational force is theoretical. Let's look at a simple example. Here's a tinfoil triangle. We put a negative charge into it. It goes up. It repels itself from the Earth. And because we're constantly putting a negative charge into it. Okay. So let's look at where is it? My, I guess it's here. Is this it? So, oh, that's not the right one. Where did it go? Upside down. Maybe this.
And while you're looking for it, I do understand that. Oh, sorry, go ahead.
Let me show you real quick. These balloons are holding this button that's connected to this wire off the floor. It's neutrally floating. Now this wire goes to a Van de Graaff generator. We're going to crank a positive charge into it. And when we do, it goes down. Did we make it heavier? Or did we just change the positive charge? Discharge it, goes back up. I just proved right there that what's making it go up and down is the electrostatic force, not gravity. Gravity is a theory. Electrostatics are a provable science, right? The MIT just created an airplane that has no moving parts. It runs on what they call the ionic wind. So when you say, is it our magnetism? That has to do with it, but that's not holding the air in. I believe that the Earth is contained. We're in a container.
Because everything has a charge. Even atmosphere has a charge. The gas is in the atmosphere. So that was my thought. Because I'm on the same page as you of like, we don't know what gravity is. It's never been completely proven. Even scientists, if you ask them, they can't exactly tell you what gravity is. So, my thought is, because gravity is still, iffy, why couldn't, our container be our electromagnetic charge holding it in? I mean, at least it's more of a possibility than gravity.
I agree with you there. And it's because, show me an experiment. That's a cool theory. That's a cool theory. Now show me an experiment that electromagnetism can hold high pressure. There's nothing that even comes close to it. Here's another problem with gravity. you got the sun holding onto the earth, but the earth is holding onto the moon, right? So
Mhm.
let's simulate that. We'll get a computer and we say, okay, we'll put a sun, this much gravity, a planet, and we'll put it in orbit, and it'll predict what it's going to do forever. And no problem. Then you add one more body, a third body. And when you add a third body to it, it goes into chaos mode and nobody knows what it's going to do next. No computer can figure out what's going to happen next. It goes into random orbits. So we have all these planets, all of these moons, all of these galaxies, solar systems, all flying around in some sort of perfect order. Okay. We had planetary alignments this year. Shouldn't something have tugged on something? How could it repeat? Like the eclipses happen in cycles, and every 18 years, that cycle repeats itself like a clock. Does that sound like a random beehive gravitational world?
No, it doesn't.
This is our solar system with 3 bodies in it. Now put, all the planets and all the moons. Don't tell me it's going to be predictable forever.
Yeah.
Right?
Yeah, I've never seen this model before, but
this is called the 3-body problem. Just look it up. Yeah. And there was recently an article. It's like scientists have figured out the 3-body problem, right? And they basically made a computer animation where they can guess 900 different times and take the average of those guesses and figure out what it's going to do for the next 5 seconds. Okay, that doesn't sound like it figured it out to me.
Mm-mm. It's just temporary.
Yeah.
Well, I guess that's why I feel like just like faith, just like somebody's religion, I guess, globe model is kind of like that. You have
it's
to have
a religion. It's a total religion. Total religion.
So, I mean, I just combined it with my religion. I'm like, you know what? God makes it work. And I'll leave it at that.
Well, that's great. Okay. Mm-hmm. And do you follow a specific religion?
Yes, I'm a Christian.
Okay, awesome. Have you looked in the app and hit the biblical flat earth? There's a 24-hour biblical channel in there, and there's also biblical flat earth videos, separate videos. If you're a Bible follower or a Bible hater or agnostic, you have to watch those videos because they'll blow your mind. They're amazing. There's hundreds of proofs in the Bible that where God says, the earth is immovable, fixed and stationary. And, he made 2 lights in the sky, one for the night, the lesser for the night and the greater for the day. So here we are. Here's our sun. Here we are in, one day of the year. And it's, we're 93 million miles away. And if I'm on the outside of this and I'm looking out that way, it's midnight and I'm looking up at the stars over there. Okay. Right?
Yes.
I'm looking at the stars. So somebody's standing on the side of this ball, feet to the middle of the ball, is looking up. Up is that way, and it's midnight, and they're looking at stars over there. 6 months later, I'm 186 million miles on the other side of the sun. Forget the fact that I've traveled, 2.5 billion miles already in another direction, and I'm standing over here at midnight, and midnight is, I can't point, is that way, right? Yeah. Midnight is that way. Okay. I see the same stars. Look forward across your room right now. You have any paintings on your wall? You have anything on the wall, just anything. Yes. So look at something across the room from you. Is that also behind you?
No.
Well, how can I see the same stars over there and the same stars over there?
Okay. Yeah. That makes that okay. That gives me pause. A lot of things I'm still struggling to kind of not grasp, but still skeptical in certain things. But that's interesting. That really makes me think.
I ask everyone this question. I always expect people to say no. Do you think you could be brainwashed? And everyone says yes. Everyone says yes. So I'm gonna get rid of that question because people are like, I don't think so. I'm hoping for that answer.
I thought you were asking something else. I thought you as a person, do you think you're brainwashable? I thought that's what you were asking.
Yeah, that's what I'm asking. Do you think that you could be brainwashed?
Well, I mean, I guess technically anybody can be brainwashed, and nobody believes that they can be.
I'm eliminating that question because I want people to say, no, of course I can't. And then I say, okay, you believe the earth is a globe. Can you give me one reason why? And then they can't. That's the definition of brainwashing.
Yeah.
You
Well, you
believe
know what?
something that you have no proof of.
Yeah. Oh, totally. I mean, I used to be a teacher, so I've seen what goes on in schools. I believe in brainwashing, that it's a possibility. I am no longer a teacher. I do not want to participate in that kind of brainwashing.
Excellent. I like it. Good, good.
I used to be a biology teacher, so I used to be in the sciences too, So I am,
Well, that's biology. Biology is a real science,
yeah.
Um, all right, so go ahead. Next question. You want to talk about
Sure,
seasons or
yeah.
seasons?
Well, here's another question that I'm kind of struggling to understand. What about a lunar eclipse? So I understand the concept of a solar eclipse, the moon blocking out the sun during the daytime, but how does a lunar eclipse happen, on a flat Earth?
Well, they tell us that the Earth is casting a shadow on the moon, and only a sphere could cast a curved shadow no matter what angle it's coming in from. Cool. But did you know that if you cast a shadow from a sphere onto another sphere, it actually becomes a straight line? Try it. Get an orange and an apple or a ball and whatever, and get a single source light and cast a shadow onto another sphere. It comes out as a straight line. Cast it onto a wall, it'll be curved. Okay. So here it is right here. So this is the shadow of a ball going onto another ball, and it actually creates a straight line.
Mm-hmm.
All right. And then if I cast it onto a plate, a flat surface, well, there's a curve. Now, I'm not saying that the moon is flat and that the earth is casting a flat earth is casting a shadow, or a round earth is casting a shadow. I'm not saying that at all. I'm saying the explanation that Bill Nye, the lion guy with the bow tie, said is ridiculous, right? If the earth was flat, we'd have an eclipse like this, okay? Nobody believes that, okay?
But my question is not the shadows though. Is like, okay, so when you have a lunar eclipse, that's because the with the angles and the way the earth is getting between the sun and the moon. But if you were on a plane, and the moon is up here and the sun is up here, and I guess like on your clock, how they just kind of go around that plane, how would the earth ever be able to get in front of the moon to cast that shadow? You know what I mean? That's what I don't understand.
It can't.
Mm-hmm.
I don't believe that the earth is the cause of the eclipse. Now, there's a thing called a Seleninian eclipse, okay? What's a Seleninian eclipse, right? Seleninian eclipse is this. Observer, if you're the observer, you're on the top of the earth.
Mm-hmm.
And off of one horizon, he sees the sun and the moon. And off the other horizon, he sees the sun on one side, the moon on the other. And they're both above his horizon, which means that all three bodies are not in line yet, and the eclipse cannot start, according to heliocentric. Okay?
Mm-hmm.
So there's no way the eclipse can start if he can see the sun above the horizon and the moon above the opposite horizon. But there's been over 50 documented eclipses, and the one just last year, I believe, where not only did it start before they got into alignment, the shadow came in from the top, right? If the earth is coming into alignment to cast that shadow, it should come in from the bottom.
The other side, yeah.
But it came in from the top. What does that tell you? Does that tell you what's causing the eclipse? No. Does it tell you what's not causing the eclipse? Yes. It's not the sphere Earth. We're programmed, brainwashed into believing that it's the shadow. And when does a shadow turn out something red? Okay. What are the eclipses? That's a great question. I believe there's some dark bodies up there. Some people think it's Rahu and Ketu. I couldn't tell you, but there's some weird footage out there. Some very, very weird stuff going on. So.
Yeah, I mean, definitely, we definitely live on an Earth where nothing is as it seems. Everything's covered up. I can't agree with you on this point that there is, there's a lot of anomalies. There's a lot of things that don't make sense, and there are things that are suppressed from us.
Right.
And totally. Yeah. I'm on board
so these are some different eclipses that happen. And if you chart them on a flat Earth map, they coincidentally make a beautiful circle. Okay. These are all different eclipses at different times. Put them together, they create a circle. What are the odds of that?
But isn't that just the map projections end up warped when you try to put a globe onto a
Well,
flat map?
this one doesn't make sense. This one is organized, makes perfect sense.
Mm-hmm.
Okay.
Well, I just thought the top is always map distortion because certain projections have certain distortions.
Absolutely, but and again, there is no perfect map. But but example, if you go back to my app, and if we turn on the time lapse, I could watch that sun go around, and right now, right there would be noon for you and me. Okay. And if I waited till the sun got over here to Sydney, and I call up my friend PK, I say, PK, where's the sun? He'd be like, well, it's down a little bit, but it's noon and it's at the high point for the day. Like, interesting. Okay. Right now, Australia is having their end of winter and their spring because the sun is moving its way back out towards the Tropic of Capricorn. The outer yellow line is the Tropic of Capricorn. The inner is the Tropic of Cancer. In June, the sun was over the Tropic of Cancer, and that's why we have our summer, because the sun is close to us. Okay? If you and I got together in February and we're sitting outside after a freezing snowstorm and we're 25 feet apart, okay, because we don't want to get the what, right? and we're sitting there and we're trying to drink a beer, but our beers keep freezing. Not good. Okay. But then somebody comes over with one of those giant heat lamps on a 15-foot pole and is holding it 15 feet over your head. You would feel that heat radiating down on you. Your beer would melt. The snow around you would melt. And I'd say, that's your sun. Where is it? You go, well, it's right up there. And I go, I'm looking at it and it's over there. That's not straight up. That's not 90 degrees. That's like 45 degrees up. Right. But then if that person walked over to me, not lowering it, you're going to look at that sun and go, it's up there. Oh, it's going down. It's going down. It's going down. And I'm going to watch it. It's going to come up, 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 up. My snow starts melting. Yours starts freezing. That's our winter. Okay. So in June, right now, I have it where we're in end of July, August, and it's coming pretty close to us. It goes right over Miami. It's pretty hot in Miami. Okay. Southern Florida, Mexico, hot. Right. But if I jump forward to July, August, September, October, November, December, in December, it's all the way out here, far away from us, lower in the sky, like that heat lamp. We see it for less time, and we don't feel the heat. In December, you can go out and look at the sun at noon when it's high in the sky, and you barely feel the heat on your face. You won't get tan. But in June, when it's close to us, you can go down to the beach, and when you see it on the horizon, it's hot. At the most severe angle, it's hot. You get a tan. You can lay down on the beach and have a good time. Okay? That's seasons. Seasons make no sense on the heliocentric model. Do you know that during our winter, we're 3.5 million miles closer to the sun than we are in our summer?
Yes.
That doesn't make any sense. And they say, it's not the distance, it's the angle.
Yeah.
It's the angle.
23.5?
The angle, because we're tilted, and when we're tilted towards the sun rays come in more direct. Baloney. And June, when the sun appears on the horizon, what is that tilt? That's an 89-degree tilt. Could it any more? It would be below the horizon. And I could feel the heat on my face. Right? Go to the beach, like it's now. I mean, today, in the next couple of days, and watch the sunrise. And as soon as it shows up on the horizon, you feel the heat on your face. Well, that's the most severe tilted. According to heliocentrism and seasons, it should be arctically cold. But it's not. You're 3.5 million miles farther away, and it's at the most severe possible tilt anyway, right? The balls can be tilted in any direction you want. It's your angle from the ground to the sun. If it's directly above you, 90 degrees, right? We have that little tilt, but when it's on the horizon, it's an 89-degree tilt. I could feel the heat at an 89-degree tilt in June, but in December, when it's at the high point for the day, let's say 50 degrees up, much more direct and 3.5 million miles closer, I can't feel the heat.
Mm-hmm. Because of our tilt. But I understand what you're saying. Yeah, it doesn't make any sense. It's kind of, yeah, it's
Doesn't
pretty
make any sense.
contradictory. I know. When I learned it in school, it kind of did give me pause. I'm like, wait, winter we're closest. I'm sorry, closer than we are any other time. But because of our tilt, that did throw me off in school when I learned it. I'm with you on that. Yeah.
These are the two biblical channels that I was telling you about. Okay,
Okay.
they're
Yeah.
fantastic. That you can go through the videos here, or just throw this on, like people throw the news on in their house to poison their minds. All right, and this will just go 24/7. And then this one here, Glowbusters 24/7, all sorts of stuff, all sorts of the best clips of the best stuff 24/7. Just throw that on. Turn off the news. Turn off Netflix. Turn off HBO, and throw this on, and become a more aware person. Let's get into why the lie. Right? If you go into the frequently asked questions, why the lie is right here. All right. And there's great videos there, but we'll talk about it today. But there's great videos that present way better than I do.
Yeah. No, I just want to address something. Sorry, I saw
go ahead.
In the live. It was a while back. Mango Junkie. He's and I think someone else. They think that you're going too fast for me. That I'm lost. I'm not. If any expression I'm wearing, I'm taking it in. I'm trying to absorb it. I'm trying to synthesize it with what I know. So I hope it doesn't come off like I'm lost. I'm because I want to understand the perspective. So I want everyone to know I am taking it in. I'm not lost. I'm just trying to, because this is like a new theory to me, because originally when I heard flat earth theory, I was like, I thought it was a joke. I didn't know it was a real thing, and then I was surprised to believe people really believed in it, and and had their evidence to support it. So so this is new. It's interesting to take it all in. I'm still willing to explore your app after this. I appreciate you putting all those resources in one place.
So let me just show you a couple other quick things. Just resources in the app. If you go to the web button, scroll down, full length movies, videos. These are anywhere from an hour to somewhere 45 minutes, hour 20, hour 30, an hour. If you can get through the first 5 and not be a full on globe denier, Earth is level. You didn't watch. You didn't. You actually should worry about your future because your brain isn't working. All right. But here's the thing. This is help. This makes you don't believe just a video, because like people, where do you get your information? YouTube has everything. It has hex haters and hex lovers on it. It has everything. Right. But these are really smart people that have done excellent work and have put it together to basically to make it a nice lazy solution for you, where you can sit back, popcorn, cup of tea, cup of coffee, a beer, whatever you want, and watch these videos, which are amazing. Like anytime one of these pops up, I have to watch the whole thing again because they're all awesome. The third one is a bunch of military people, right? You said was it your father that was in the military?
Yes.
Military whistleblowers showing you that their weapon systems, their sonar, right? A submarine can see another submarine at the bottom of the abyssal plain, over 100 miles away. There should be a mountain over a mile high between them. Okay, but they can see things. The guys that shoot the giant gun that goes over 100 miles, there should be a hump of water over a mile high. Okay, that they'd have to go over. Okay, nonsense, right? So that is a fantastic resource. Here's the thing: people believe they live on a globe, but they're unwilling to look at the evidence of a flat Earth, and they're unwilling to look at the evidence that proves the globe wrong, and they have a false belief in what flat Earth is, and they can't come up with a single reason why they believe the globe. That's brainwashing.
Yeah.
Okay. If you like books, there's also books, amazing books.
Say that again about the books.
If you like books, there's amazing books. These top ones here are for kids and adults, but they're great for kids. Okay. 16 Emergency Landings, another fantastic book. Just really, really great stuff. If you're a book reader, if you want to read books, I love having books. They're fantastic.
So no, thank you. I appreciate it. No, because I do like books. I like a little of everything. I like to mix it up. So I will look into that. Like I said, I bought the app. I find it really well organized. Really, you did a wonderful job with that, and I appreciate that
it
all the resources are in one place. And I had another question to throw at you. If you were at an hour, I don't know if you have any more time.
yeah.
But what would it take, do you think? Like, let's say, Hex, Pulse, all of us Hexicans, like it went, it mooned. We were all filthy rich, and we wanted to put our money together for like an expedition. We wanted to be able to explore these things. What do you think it would take? Put aside the fact that the government will probably try to kill anybody in the process. But what would it take? What kind of experiments do you think it would take to prove this, or what kind of expeditions would it take to do that?
Well, so you know about the Antarctic Treaty, right? So the
Yes.
Antarctic Treaty, all the countries in the world fighting over resources, fighting over everything, they agree on
Mhm.
two things.
Mhm.
Don't disturb the penguins or the ice. Nobody can go
Mhm.
there. It's guarded all
Mhm.
the way around, right?
Yeah.
There's 7 different military bases on islands surrounding all around the earth. Nobody can go there. And they also agree that everybody has to get this. What's going on there? Okay.
Yeah.
What is going on there? This is about controlling the herd,
Mhm.
controlling the human population. So a simple experiment would be, 2 airplanes flying the opposite directions around Antarctica, 1,000 feet in the air, just keep the shoreline in view, and they should come around in 10 to 13,000 miles later. But that's not the way it works. The Earth is not set up like that. And the last person to try to go around it was Captain Cook, and he went over 60,000 miles. It took him 3.5 years. This is Antarctica. It's the shoreline that surrounds our pond. It holds our water in. Okay, and it's not. This is over 60,000 miles. Right, the equator is 24,000 miles, and as you go down towards Antarctica, it should get smaller, but it gets bigger.
Mhm.
That's the problem. Airplane flights prove this. Have you looked at the airplane flights?
No, I have not seen the airplane flights.
So let's take 2 minutes here. I think you'll like
Sure.
this. So, where is it? Where is going on here? So if you were on, so we got the globe. The top half is north. The bottom half is south.
Mhm.
Right? The equator goes around the middle. If you were going from any 2 airports, anywhere in a north airport to another north airport, would that plane ever need to go below the horizon? Below the equator?
Would it ever need to go?
Would ever need to go below the equator? Like if you're going from, I don't know, anywhere, Chicago to Moscow, to any 2 northern locations that are
Yeah.
both, would it ever have to dip below the equator?
I mean, eventually, if it's following the curve, it will dip below the equator,
No.
right? I'm sorry.
No, it's okay. It's okay. So we have our northern hemisphere
Yeah, I
on the
need
top.
visual. Thank you.
Yeah.
Mhm.
Okay, and it's see through because it's green. You would never go below the equator to go back up here. You would never go down and then back up.
Oh,
You would
I
just
get
go
what you're
across.
saying.
So
I'm sorry. I understand
so
now.
you just go
Yeah.
across. Well, that's true. And guess what?
Mhm.
All flights from northern locations to other northern locations never cross the equator. Interesting. No, not really interesting. It's kind of like, yeah, duh.
Yeah.
Well, here's the problem. Southern flights do cross the equator.
Mhm.
Okay. So when you look at southern flights, for example, from this one from Santiago to Johannesburg, it goes all the way up to Senegal across the equator. I think that's
Okay.
across the equator. It goes all the way up. Why didn't it just cut across here? Okay. This is the equator, the blue line. And it's because Senegal is a good spot to get more fuel because this is a long flight. Let's look at
Mhm.
another one. And then I'm gonna take this one home for you. Okay. Going from Australia to Montevideo, it stops in Los Angeles. Well,
Mhm.
why the hell does it go all the way up to Los Angeles and all the way back down when these passengers want to just go over here? They should
Yeah.
just cut across here. Well, look, it's a straight line.
Mhm.
It's a straight line. So people say, well, it's because the airlines have to go to their hub, or people wanted to go somewhere else, connecting flights. Not true. There's plenty of people that want to go to these places. Plenty of people want to go to Peru. Why do they go all the way up to Los Angeles? Why do they cross the equator twice? Right? Why didn't they just cut across here? It looks like they're more than doubling their trip. Okay. So let's look at some emergency landings. Okay. So sometimes someone has a baby, heart attack, need to land the plane. Okay. Mm-hmm. Here's a documented flight from New York to Hawaii. Emergency happened right about here. They went like 1,000 miles out of the way to Seattle, and somehow they got there in 15 minutes. What? Well, let's look at it. New York, Seattle happens to be right on the trip. Let's look at another emergency landing. London to Islamabad, and stopping in Moscow. Moscow, way over here. I don't know, is that over 1,000 miles? Moscow happens to be just on that flight path, right?
Yeah.
Let's look at another one. Wait, one more. Let's do two more. Another one stopped in Calgary. Look how far Calgary is out of the way. Look at Calgary here. Happens to be on a straight line. Which map are they making up and which map is reality, right? Same one here. They love Moscow, right? Why did they go all the way here and how did they get there? Now, I'm just showing you memes. Don't believe any of this crap, okay?
No, I understand.
Lucky for you, Eddie, Flat Earth Banjo, has made it easy. He made a book. You can buy it at lulu.com, or it's free online if you just want the PDF. He documented it all. Flight routes, times, stories, news articles, everything. It's all documented in here. 16 emergency...
I'm sorry to interrupt, but doesn't the Coriolis effect come into play at that point? And that's why there is curvature, with the flight paths, that they're not necessarily the straight line.
Coriolis, well, you're grasping at straws here, and they say that they do the Great Circle route. It has nothing to do with Coriolis. If Coriolis was real, how do we send a balloon up to 120,000 feet and it lands east of where it took off from, when it should be landing thousands of miles to the west, because the Earth is spinning to the east, spinning out from underneath it, right? Coriolis is a made-up effect, okay, that no one has ever proven, right? And so if this is the equator, right, it's just kind of a flat version, and these are the speeds that the Earth is spinning underneath you. So if you took off from here, the Earth is barely moving. Right? When you got out here, how the hell could you even land? The Earth is moving 1,000 miles an hour from underneath you. If you took off from northern Alaska, maybe it's moving 200-300 miles an hour. You fly to Ecuador, you want to land on a north-south runway that's moving sideways at 1,000 miles per hour. Your mind can't wrap around what I'm saying because you weren't taught to think this way.
Yeah, but what about, let's say you're on top of a train and you're moving with the train and you jump in the air. The train's not going to move below you, you're moving with it. So wouldn't that be the same thing with the planes?
No, because on a train, if you were on top of the train and you jumped, you would go backwards because the air would push you backwards. But if you were inside the train and the train's moving consistently, no, you wouldn't. But are we on a train? Is there a container surrounding our world? I mean, if the Globers say that the air is spinning with the Earth, okay, that's interesting, right? So an air molecule right here is moving, if this was the equator, is moving 1,000 miles an hour, okay? But an air molecule up here, it's going to, if it to turn with the Earth, it has to go faster than 1,000 miles an hour because it's got to draw a bigger circle rather than this smaller circle, okay? So the air molecule up here, as the balloon goes up, it has to gain speed just to keep up with the turn of the Earth, right? In reality, it should go up. The Earth should spin out from underneath it, and it should land thousands of miles to the west. But they don't. The many balloons go up. I think the Red Bull jump went up, and he landed east of where he took off. Okay, no sniper has ever accounted for curvature, but there is one video of a sniper claiming that he does. Many of our researchers are close with many snipers, military snipers, and they're like, never, ever, ever do we account for that. And it would be different for every shot. Like if I'm shooting across the equator versus at 45 degrees, how the heck are you can have time to calculate that? There's no way to calculate that. It
Yeah.
changes.
Yeah. I see what you're saying.
Are you
Um,
okay? Are you all right? Let's take a break. Are you
no,
okay?
I'm good. I'm good. I just, I still, I'm still skeptical, but like I
I,
said, I'm going to go on your app. I'm going to look at that documentary that you said, you watched.
that whole list
Yeah.
of documentaries. But people think that flat Earth is dying. These are
Mhm.
just the people near us. Look at this.
Yeah.
These are just the
Wow.
people near us, and the app makes it so you can actually contact these people. You can send out group messages. You can message people. You can check out profiles. People are using it as a dating app. And by the way, you're going to need. Are you single?
I'm not going to
You
answer
don't have
that
to answer
live.
that. You don't answer that. But once you become a flat earther, you're not going to want to date anybody else. So this is a beautiful resource for you if you needed it. That's all. That's all I'm saying.
Yeah.
So
Well, you know what? It's interesting because I never realized just how many people did believe in it. That,
right.
that was a big surprise to me. That they're, that it, because I guess media, internet likes to make it seem like it's just this rare, strange thing. But
That that
it is kind of, yeah, mind blowing to realize that so many
so
people are behind
not every
behind
flat earther has my app. Look, these
Mhm.
are the people that have my app. Okay, this is actually only some of the people that have my app.
Mhm.
Right. Let's look at the UK. Right, and this is just the beginning. There's so many more people waking up to this. And the question you have to ask yourself is, can you go online and search for Bigfoot and the Loch Ness monster and aliens? Sure, you can find all sorts of stuff. You put up a video today on aliens or any one of those topics, and somebody searches for that topic, they're going to find your video. They're going to find all the videos about it. But if you Google flat Earth, you're going to find nonsense, just like you did. You found my interview, my setup
Mhm.
with not a Professor Dave, and it was supposed to be where I got to ask questions and he had to answer them. None of that happened, right? So, and Google thinks that that's actually helping their cause, but it's not. That video is waking up so many people. So many people reach out to me and go, I don't believe I'm not a flat earther, but I
Mhm.
saw your Professor Dave video. Why did he act like that? And then I send them that list that I just showed you, the full
Mhm.
movies list. And then they get
Yeah.
back to me. They're like, holy crap, this is real. What do I do now? And I'm
Oh
just like,
well.
welcome, welcome, welcome.
Yeah. So that is what comes. I mean, because I know that when I'm just searching YouTube, that comes up pretty prominently. So even if someone's using a Google search, that's going to come up. They
You're going to
also
get
can.
all nonsense. You search my name, garbage. You search flat Earth, garbage. You search the name of some of the channels. Like one of the top videos is ODD, A Stranger's Guide to Flat Earth, 21 Questions. Pretty specific. It's gotten millions and millions of views.
Mhm.
Okay, and it won't come up. It won't come up. You'll get Professor Dave. You'll get all sorts of stuff. Why aren't they showing you that? Why are they hiding this information? Because honestly, anybody that watches that video, which is right here, right? The
What is it
top
called? The
video in this
Stranger's
list, it's
Guide.
called A Stranger's Guide to Flat Earth, 21 Questions.
Okay.
Okay. Um, and you watch that. What it basically is, it's the top 21 questions.
Hmm.
And and it answers them in 2 or 3 or 4 or 5 minutes each.
Okay.
And if you watch that, you'll be like, all right, I thought I knew the answers to these things, but wow, that's interesting. And then you start looking deeper. Okay. And
Hmm.
it actually, that's what my frequently asked questions page is based on. We're adding more and more stuff all the time. But once you like the eclipses videos, right? Watch these videos. These are videos that if you search them, these won't come up. And we show you what you're not seeing. We're showing you possibilities of what could be.
Okay. Yeah, because I did notice some of those videos were unlisted. Yeah, so you wouldn't find these
Well,
outside of
no,
the.
no, 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 no. Most of occasionally you'll find an
Some of them,
unlisted.
yeah.
Like no, the featured. No, no, none of these are unlisted. Okay,
Oh, then I
but
must have clicked something else.
no.
Okay.
You. Every day there's a new video that shows up. Right, like
Mhm.
right here, Peggy Hall. You know who Peggy Hall is?
No,
She's the healthy American. She just came out, flat and stationary, baby.
really.
Space is fake. Okay, and she destroys the James Webb in today's featured video. Anyone listening? FlatEarthDave.com. A link to the app is there. Be careful. I always tell people go here because there's also a knockoff by the Flat Earth Society people, by the Ron Media Group, they call themselves, that tried to steal my app and send you bad information because they don't want you to have my app because it bypasses Google information. So just remember, it's called the Flat Earth Sun, Moon, and Zodiac Clock app. Long name. Nobody can remember it. But Just go to flatearthdave.com, click the link there, Android or iOS. It's $3. And have a good time. There's a subscription for $11 a year if you want to be able to send messages to people and a couple other things, but you don't have to do that. Only if you want to. But $3, you get the app forever with all of the resources.
Yeah, which is a good deal, I'd say.
Just go read. If you're nervous, go read the reviews. Just go read the reviews. Highest rated app in the App Store.
Yeah, and you know what? And I can tell you guys too. Like, yeah, $2.99. I figured it was worth it, and I do feel like it was worth the $3. Ton of resources in there.
Right. So. This is your world, right? We got a moon spinning around the Earth, spinning around the sun, flying through space. Just study this for a little bit. This is ridiculous. This is absolute insanity, right? And when you fully understand, none of it makes any sense. One thing I always like talking about, well, what, if this is the world and this is Antarctica, what's out here? What's out here in the outer space, right? And I say, well, what if the world was set up like this? We're here. This ring is Antarctica. It could be couple thousand miles wide, right? And then out here is extra land, extra territory, extra terra, extra territory. If somebody lived out here and came to visit us here, what would we consider them?
An alien.
No, an extraterrestrial, extra terra. Words have meaning from the outer space. Extraterrestrial. So here's the thing.
Beyond Antarctica.
So, and then it gets worse. I mean, you really want to go out there. What if we lived here? And there's extra terra here inside of our pond. And then there's other ponds, other worlds, right? This is a possibility, a scientifically feasible, workable possibility. Outer space, a vacuum with burning gas balls, gravity holding, planets and moons, everything working perfectly like a clock, people traveling from unimaginable distances, aliens that way. That's scientifically impossible. Think about this. The closest star is 25 trillion miles away, right? 25 trillion miles away. That's our closest neighbor. The other ones are magnitudes farther. That one happens to be really close, 25 trillion miles. Ash, how long is 1 trillion seconds?
Oh gosh,
if you guess within a week, I'll give you 1,000 hex.
Oh gosh, me and numbers. So 1 trillion seconds.
Yeah, 1 trillion seconds.
Would that be like 5 years? I can't even.
Oh, very close. 31,000 years. Okay. So think about this. 31,000 years. That's how big a trillion is. 1 trillion seconds. 1 trillion seconds. Let that sink in. 31,000 years. So if you were traveling at a mile per second for 1 trillion seconds, you've traveled 31,000 years and you've only gone 1/25th of the way there. A mile per second. That's fast. No one's ever gone that fast. Let's speed it up. 100,000 miles an hour. No one can even fathom that speed. It would take you 28,000 years to get to the closest star through fake space, which doesn't exist. Vacuum next to gassy planets, right?
Isn't the closest star like 10 light years away, though? Isn't it a little closer?
4.5 light years. 4.5.
Okay.
And that's about 25 trillion miles.
Gotcha.
10 is worse. 10 is worse. 10 would be, 70 light years. Okay. Yeah. That's crazy. So there's tons of resources in here. And just going through these images, right? And at the end, we have it's just loading because I just loaded a test version. We have all sorts of really mind-provoking memes, which will blow you away. And people go, memes? I don't like memes. Well, you were brought up on this meme. Okay, this is a meme. Nobody knows what's below 7.5 miles.
Never heard anyone call that a meme. But
well, think about what's a meme. A meme is a depiction that has zero proof. I mean, this is a non-scientific meme. The deepest hole ever dug is the Great Borehole in Russia. They went just short of 8 miles, and they couldn't get any deeper. And while they were digging, they were using ground-penetrating radar to see what they're going to hit next. And they're like, all right, no more rocks. They hit rocks. No more water. They hit water. They were wrong. So they were digging through they were digging through, an example would be an apple.
Yeah.
They drilled halfway through the skin of an apple, and they
Mm-hmm.
were wrong every step of the way, but somehow they know what the next 4,000 miles to the core is.
Mm-hmm.
That's a meme. It's a meme.
Yes.
That is a meme. A meme.
Yeah.
There's
I know. I
zero.
mean,
Sorry, wait. And what's in the center of this? A molten magnetic core.
and then
They're
the solid
laughing at
one.
us. Well, they say there's a molten magnetic core, and whenever you heat a magnet up, it gets to, before it melts, it gets to the Curie point, and there's no magnetism. The magnetism disappears. So a molten magnetic core, they're laughing at us.
Mm-hmm.
They're laughing at us.
Now, okay. Yeah.
Ashley, go in your app when you go into the friend finder, and then on the top here, there's this little button here. This is for if you do referrals. You can change your referral code, change it to Ash or Ashley before someone else does. And then anytime you tell people when you become a full-on flat earther, and you're like, here, get this app, say, hey, use my referral code, right? And type it, and they can type in whatever you put. Remember, it's cap sensitive, right? So if anyone gets it and she doesn't give you her referral number, put in DITRH, right? And then it does some cool things. So a lot of additions coming to the app.
Okay. Yeah, I see there's a lot of adoption. So congratulations. That's amazing. It's really wild to see how many people are using it. Like I said, how many people are into the flat earth theory. And so like I said, I'm still going to do exploration on it. I don't feel completely convinced, and not the fact that I'm shut off to it. I'm open. I mean, and I will do more research on it. I just haven't seen anything that really grabs me yet. There are things that give me pause, but
so we can see farther than a globe should allow us. That's not good enough.
Mm-hmm.
We can show you that there's no scientific proof that you could have atmosphere next to a vacuum. That's not good enough. No scientific experiment ever has proven axial rotation or curvature. Yeah. That's not good enough.
Okay, the Michelson-Morley experiment did throw me off.
Yeah, I mean, I don't even like that one because, these are things that we can see ourselves. I mean, go out in nature. Imagine us corkscrewing through space at all those different directions. You're gonna be nauseous. And then shake that off, sit down, close your eyes, and imagine yourself perfectly still and stationary, just like it is. Yeah. Right? The tiniest earthquake sends water in all different directions, right? And that's a tiny little shaking, right? A tiny little shaking of that will send like pools jumping over their rim. Yes. But the Earth is moving in 4 different directions at once in curved directories. That's acceleration, right? This is a small little earthquake is doing this to a pool, all right?
Yeah,
and then we go out. Yeah, we go out in nature, and we see, perfectly flat, measurably, testably flat water. Large bodies of water at rest lay flat. Can't have high pressure next to low pressure. I understand it's a lot to take in, and your whole life of programming, your whole world has been built around a sphere, and that's where. It's like I'm ripping the rug out from underneath you, but the good news is there's actually a foundation below you. So let's get into why the lie before we end. Is that okay? We good?
Yeah, definitely. I mean, because I'm with you on that everything, with knowledge, everything with information is a form of control. And the fact that things don't add up, I do believe that is tying into control. And I agree with you that a lot doesn't add up. I just, I'm still, trying to grasp why it doesn't add up.
So last question, and then just why the lie. I'll finish with that. What's the number one reason you live in a globe other than NASA told me or my school book told me?
Well, I guess it's, like you said, programming. So that is the programming. And that's
not a reason. That's like saying science. That's like saying science.
It's just, I guess, the faith in the globe that I grew up in,
It's a religion.
So not my religious faith, but just,
It is, no, it is your religious faith because there's more proof in the Bible of things than there is proof of the globe because the globe is provably, scientifically impossible. So why the lie? What if you could have something the size of a roll of quarters that would heat your house forever or that would power your house forever and your car? Okay. So you had free energy and free heat,
Mm.
free fuel. You never needed to pay for that again. Would that free up some of your time? Sure would. Okay. What if you found out that, hey, you know what? I don't know. There's some tyranny going on here. I'm going to go somewhere else. There's more freer lands. Well, that would give you some options. What if
Yeah.
you found out the Earth doesn't have as many people as they're telling us, and it's not
Mm.
overpopulated, right?
Yeah.
Every family in America could get a half an acre in Texas, okay? And the rest
Mm.
of the country would be empty, right?
Yes.
And I think every family in the world could, same thing in Australia, and half of Australia would be empty, okay? What if you found out that there is no shortage of water, there is no shortage of food? That's ridiculous. You put a seed in the ground, water falls from the sky, delivered by God, if you will, and food will grow out of the ground. Okay, there's a shortage on intelligence and an abundance of stupidity where people have lost their minds. If you're spinning out of control, lost in space, afraid of asteroids, afraid of nuclear bombs, afraid of shortages, afraid of overpopulation, afraid of the boogeyman thing, and you're living in fear and you are not using your potential. What if you knew that your thoughts create your reality? That you knew that you can manifest. Absolutely.
Okay.
Right. They don't want you to know the power of your mind. They don't want you to know that you're at the center of creation. They don't want you to know the people that are running this place, the controllers, they don't want you to know that they have no power over you other than in your own imagination. Right. We have God. They don't give us our rights. They take our rights away from us and then they offer them back sometimes, but not really. I mean, look what they've done, with travel and everything. We have God-given rights. I get my rights from the Creator, and nobody can take them from me. And I don't listen to their nonsense, right? You work your butt off to pay for the things that should be free because free energy exists, but they don't want you to have this technology. They take 40% of your money, and at the end of the year, they give you 2 or 3% of it back, and you're like, yes, I got 2 or 3% back. Okay, they're giving you money which is not real. It's a faith thing because if everyone stopped believing in dollars, it's gone, right? Yeah. There's nothing backing it, and they're inflating the crap out of it. Okay, so we're playing on their monopoly board. We need to get off their monopoly board and start using our own trackable, not trackable, just real money that can't be screwed with. Okay. I'm a big fan of Hex and some other privacy cryptocurrencies. Okay. And we need to stop listening to them, right? If everyone listened to this interview tonight and everyone goes, hey, you know what? Dave's making a lot of sense. Let's just ignore the government's done. They're finished. They're dust. They're dust. They're insignificant. We don't even know who they are because, God, man, government. Government has climbed on top of man, is crushing man, trying to get on top of the Creator and take and they're trying to become the gods of our worlds, and they're not. Yeah, so why the lie? Why the lie with all the stuff going on in the world, with all the deceptions going on in the world? This is how they get away with it. If you're lost in space, spinning out of control in a distant God or godless universe, or even if you believe in God, but you're in this ridiculous system, you've lost your foundation. You're not connected to the earth. You're not appreciating the creation. There's some verses in the Bible that basically say, once you see my creation, you can no longer deny my existence. And the people that are running this world, and I use the word people liberally, do not like the Creator. They hate the Creator, and they do not want us in a position where we can't deny creation, right? This world is intelligently designed. The sky clock proves it. The world is just so amazing that I like when I go outside, whether I'm in the middle of a city looking at these old buildings that make no sense in our timeline, or in nature looking at these rocks that I realize were used to be trees. It's an amazing world, but they don't want us at. Here's another thing that flat earthers all have in common. Never for a split second, no matter what, are we ever bored. Ever. There's not enough time in any day. And if we wake up at 3:00 in the morning, with insomnia, we're like, yes, I got 5 hours before I have to talk to anybody, right? I can go do some research, right? Because
I'm waiting on that page. I'm never bored. I'm like, how can you possibly be bored in the world?
That's good. So you're on your way. You're on your way. It's like you're having this and I say women do this more than men, and it's not a sexist thing at all. Women like to build a safe family tree, a safe world around them. And when someone comes and goes, "Oh, this is all bullshit," you have to change it. They're like, I don't want to let go of that. But when you let it go, you place yourself at the center of creation on a level earth. Okay, you place yourself in a position where you are part of creation, where you are more powerful than anyone wants you to know, right? That's the reason for the lie. And that's how they got away with all this stuff since 2020 and everything else before. It's all a lie. Have you looked into Tartaria and the mud floods at all?
I have. That is fascinating. Like I am, very intrigued by it, but there's so much to that.
Yeah, there's tons, and there's a in the app on the web page again. We have the mud floods button. We keep adding great videos there, and if you go over to the homeschooling page, which we're building, we have our true history, which is basically this is just John Levy's stuff, and John puts out a new video, 20-30 minutes every weekend, and he just looks at the world with different eyes. And once you get into that, everything changes for you. So, what difference does it make? I still have to go to work. What difference does the shape of the earth make? That's what I said. What difference does it make? I still have to go to work. My entire life has changed. I no longer go to work. I still work. I do this. I've never worked harder in my life, but if they say, do what you love and you'll never work a day in your life. Well, I work all the time. I mean, it's insane, but I love it. And I work from my home, and, life, I built myself up, college, corporate America, left corporate America, started my own business, CEO of my own company, making more money than I ever thought. And I walked away from it all, the American dream, to do this because this matters.
Wow.
This matters. All right. So, Ashley, before we go, and you can, if you want to say anything else, please, no problem.
Sure.
Your best reason that makes you think we live on a globe. I just want one. And we didn't even get into NASA. Like, NASA's totally fake. Not a space agency. NASA, not a space agency.
Oh, no, I'm with you on that. I don't trust NASA.
Totally
I don't believe NASA. I believe that there's a secret space program, but that it's not NASA. The
secret space program is the secret propulsion program. They use electrostatic, charges, and they use, electromagnetism. And it's the secret outer space program, where they have vehicles that can run, not on fuel. And that's kind of right in front of our face. It's a whole nother rabbit hole. But this is the secret space program here on flat Earth, going to the other worlds here on flat Earth. Everything's here on flat Earth. Read the Iron Republic in the books section. Scroll down a little bit. Iron Republic, get that book. Mind blowing about, a politician that got a ship, went to Antarctica, went through, found an opening, and then was lost at sea for a couple months, then found more land, found a city. And it was an advanced civilization that moved away from here in the 1600s. This was in the late 1800s. And he was showing all sorts of advanced technology stuff that, this was written in 1901. And, flat screens, flying cars, all of the stuff in this world here. But whether it's true or not, and it rings true to me, is they were talking about more land beyond Antarctica in the late 1800s. Okay. What's going on? They were teaching flat Earth here. And here's something. If people, we want to see a great movie, it's also on my website, flatearthdave.com, but it's thenextlevel2022.com. Buy yourself a high def copy of that and watch that video. I'm in it. Okay. And that's not why I'm telling you to get it. And you'll
2022.
The next level 2022.com. Everything's at flatearthdave.com. There's a big banner there.
Okay.
And get a high def copy of that and watch it on your big screen, and don't watch it while you're multitasking. Put your phone down, put your computer down, bring in the family, bring in the kids, watch this video.
Okay.
And then you'll be like, I need to do more research. There's more. And then you'll understand that what I'm telling you about, this is our chance. Right now, we're going into the dark ages if we don't wake up. If people don't wake up I think
we're already in dark ages.
We kind of are, but we have right now, we're in a unique position because right now, don't know how long it'll take. People all around the world could be listening to this, right? Somebody can tweet this, and people in Japan and China and wherever, everyone could watch it. and people can learn this stuff. We have this opportunity right now, and everything can change on a dime. The only people go, well, what different? I'm only one person and I can't do anything. And the governments have power. That's in your imagination. If everyone just said no, it's over. If everyone said no, it's over at the same time. It's over.
Yeah. Yeah. No, and unfortunately, not just with this, just everything. Everybody's in some sort of programming that they can't break free from. And then the second, especially these 2 years with everything happening, that is the perfect example of people kind of controlling programming and people not being able to break free from that. And when you present people with the opposite information, they just shut down. They can't handle it. Right. So, so I think that is perfect example of it.
One other thing on the app, I try to anybody that has a flat Earth product or something that I really like that's good, for getting away from the control system, or just cool stuff. I feature it in the app under the shopping cart. And if you go to shopping cart, these are flat Earth stuff. Like I have my t-shirts, which I'm wearing one. It's hard to say. Flat Earth, they're very subtle. Okay. Yeah, very subtle. So that's in my t-shirt shop there. I've got flat Earth coffee. If you drink coffee and you want to, it's good, it's fun to put in your break room at work or just on your kitchen counter. But if we scroll down a little bit, we have hex and pulse chain information. Nice. Great playlist here. This will get you. Listen, right now the crypto market is in a bear market. We'll call that. This is the time to learn about crypto. This is the time to get all your information, because when the market turns, everyone's going to panic. Like, what do I do? How do I do it? How do we get a wallet? What is a wallet? You need to learn this stuff now, because now is when, fortunes are going to be made.
Exactly.
So,
yes.
So in the app, if you go to the shopping cart, and if you don't know anything about crypto, Jaron from the Jaronism has a crypto school. You can take private lessons. You can do the group class on Fridays. It's amazing and super affordable. Check that out. Learn about crypto and don't invest in it. Learn about it, but not investing in it and not knowing about it is not responsible. No. Learn about it and then make up your mind. It's like people that go, Earth is a globe, but I'm not going to look at the information, right? It's the same thing. That's ignorance, right? Learn about this, because this is our key to get away. We keep playing with their monopoly money and on their spinning ball, we are prisoners for life.
Oh, totally. Oh, yeah, I'm with you. Like, this is the way to break free, because finances, just like information and everything else, is probably the biggest tool of control being used right now. So can you imagine so many people breaking free out of that financial system from them? That'll be devastating. And that's why there's so much, wanting to regulate crypto. There's so much pushback about crypto, is because they're afraid. They know.
Absolutely. Yeah. Actually, and also, as you become a flat earther over the next week, when you realize, okay, I'm giving up the ball, there's Flattoberfest under the meetups button, October 21st for 2 or 3 days in South Carolina. Biggest meetup conference, music festival. It's going to be amazing. Check it out. Yeah, it's if you don't have the app, just go to flatearthfestivals.com. Tons of resources. There you go.
Yeah, definitely. Thank you for walking us through your app. Really, it really is like the best place to go without censorship. It seems like.
And another thing for anyone that still thinks I'm crazy. If I can get out of here, what is going on here? Anyone that still thinks I'm crazy, every day on the app there's a featured video, and I say watch the featured video every day for 2 weeks. At the end of that 2 weeks, if you think you have a glow proof, first check the frequently asked questions to make sure it's not answered in there. If it's not, send the globe proof to me and you win 3 Bitcoins. 3 Bitcoins. What's that, 70 grand right now? Not really.
No.
So, yeah, they have like Aristophanes, sticks and shadows. And I was like, did you hit the Aristophanes, sticks and shadows button? Okay, sticks and shadows button right here. And then you'll realize how silly that argument is. There's, check it out. And then, I'm going to give you my greatest flat Earth proof. You ready?
Yes, tell me.
There's no globe proof. That's my proof.
Yeah.
There's no globe proof. It's the most convincing to me. it's the one I like the best. But there is proof that we're not on a globe. So we're not on a globe. Is it flat? Yeah, appears to be. But could it be something else that we don't even understand? Sure. But it's not a globe. We can see too far. We can, every test shows we're not moving. There is no curvature. And that's that.
Yeah. Yeah. No,
Are you
I hear you.
exhausted?
No, I understand. I understand that there isn't a lot of proof, or every piece of supposed proof about globe Earth does have an argument against it in the flat Earth theory. I'm not gonna. I don't deny that.
Well,
I'm just not
the
there
flat.
yet.
I understand. The flat
Yeah.
Earth theory has lots of proofs. The globe Earth theory has zero proofs.
Mhm.
So you'll get there.
Yeah, until we can go explore it ourselves. Maybe,
Um,
maybe I'm
on
being
the
stubborn, but that would
well,
be awesome.
you are, but that's okay. And you know what? Listen, anyone that just goes, oh, hey, the Earth is flat without actually looking into it at
Uh-huh.
all, that's irresponsible. That's not
Yeah.
right. Um,
Mhm.
but if you don't want to wait for the challenge, you can hit the archive button right here,
Mhm.
and then that'll give you every one from this month, and then the little pancake at the top will give you all the previous months from all the previous years.
Okay.
Bring food and water if you click that button. Okay.
You mean it would be one of those binges where you're just like dazed?
You'll be like,
Yeah.
holy crap. Well, that's what happened to me. And there wasn't that much information when I was looking in 2014, 2015. But YouTube would feed you all of someone would upload a flat Earth video, bam, you go, hey, you want to watch this? You want to watch this? And then they change the algorithm where it's all nonsense.
Yeah.
But it's fascinating. It's life has never been better.
Really? So you feel like you're in a, because I think it scares a lot of people if it were to be the case. Me, I'm like, okay, if I did find out, or sorry, if I did come to the belief of flat Earth, then I don't think it would be jarring. It wouldn't be shocking. It would be cool. It would be something new to explore. But I think it is scary for a lot of people to, yeah, I agree, to challenge your beliefs. Whether it be convincing a flat earther that the world is a globe, or convincing a globist that the Earth is flat. It's scary to have your beliefs rocked.
I know the
Yeah.
the issue is the people that believe it, they can't come up with a reason why other than, that's what I was told.
Mhm.
That's what the textbook
Mhm.
said. That's what,
Yeah.
so many people believe it, and they haven't looked into it. So,
Mhm.
you're looking into it, you'll get there. And by the way, it makes everything make sense. All the people that talk about disclosure and aliens and government
Mhm.
letting us know, they're all looking into outer space. Look into the outer space. Why are all the big telescopes in the south looking out, not looking up? Okay, they're looking to the outer space. It all makes scientific sense here. So
Gotcha.
once you understand that
Yeah.
disclosure is just a couple thousand miles away, not
Mhm.
trillions and trillions and trillions and trillions
Uh-huh.
of unimaginable miles
Yeah.
through scientifically impossible space, I prove that space, gas balls burning in a vacuum. Okay, space is impossible. Why are we talking about anything in space? Space is
Mhm.
impossible.
So then what is it if it's impossible? What is it out there? Do you think
Nobody can
is it
get above, I think it's like 73 miles. That's
yeah.
where, if you look at the Go Fast rocket, it went up, it hit something at
Mhm.
73 miles. And so what's above there? Well, the Bible says it's water, right?
Mhm.
Bible says it's water, but for those of you that don't know what the Go Fast rocket is, this is an amateur rocket. It was launched in Arizona, and it gave us an uninterrupted camera feed sideways and down. This is the down view. Unlike NASA, watch any NASA video, edit, 7 edits before it even clears the tower sometimes, okay? Because it's a movie. This was going, and then all of a sudden it hit something, and if you could hear it, it goes plunk, like into water, but not quite that thick, right?
Mhm.
But the more interesting part was that when it turned on its side, this is a little sped up. They just did it for time. When it turned on its side, all of a sudden you can see the moon. This little dot right here, that's the
Yeah.
moon, right? Horizon's looking a little flat, right? But then if we go to timeanddate.com, when this was taken off, well, it took off right here, and the moon was over Australia,
Mhm.
right? If this is the Earth, That rocket was a millimeter, barely, off the top of this ball, and the moon was down here.
Okay. It was on the other side of the Earth.
How, how do you
Yeah.
see the moon?
Huh.
How do you see the moon?
Interesting. I've never seen that footage before. But you're saying it blatantly hit something. But
Well, so here's the thing that happened, and there's even flat earthers out there that have gotten psyop by this. It went kerplunk into something, okay, and it went kind of viral in the flat Earth world. It was like, what is this? You know, everyone's freaking out and all this stuff. And then a couple weeks later, all of a sudden, a video shows up on the internet that's being pushed out to everybody, going, oh, it's a anti-spin mechanism where it's a yo-yo where two yo-yos shoot out from the rocket. And as it wraps around, they slam into the rocket and stop it from spinning. And they show literally a 15-second video of this little model that does it really roughly. And they're like, oh, that's what it is. It's so they can do scientific experiments. Bull crap. It's a made up damage control story. Not buying it. And then there's been NASA whistleblowers. You know, again, the whistleblowers are unnamed, so we can't prove it. It's all hearsay. But saying that there is that it gets thicker and thicker and thicker, and then it becomes solid. But they're not allowed, even though they have the technology to go up that high, to explore it. And then if you watch some of the SpaceX videos where they're launching at night, it looks like they're skimming across water. Turn the video upside down, it looks like a boat on a lake. Okay. And so it's fascinating, but you know, space is scientifically not possible. Vacuum next to pressure, impossible. What is it? I think it's liquid. I think it's water, but I don't know.
And so the moon and whatever local celestial bodies we're seeing, they exist in the water, or are they below the firmament?
Well, that's a great question. And the answer I have is go out every month for a week. The moon is in the day sky. Go out and look at the sky when the moon is up there. And the app will show you. Right now, the moon is actually right behind the sun. So in a couple days, you'll see a moon in the sky because the sun is going to outrun the moon. Yeah. And look at it. You'll see blue sky behind the moon.
Okay.
You'll see that that what we're seeing is here within the atmosphere. Okay.
Interesting. Okay. Got it. Because I never understood what people meant by that with the firmament. Okay. So it does have the potential to be inside the firmament, that it's not existing out there.
Can I show you a video? Do we have a couple minutes?
Yeah.
So in the eclipse button on here, we go down. This is a video that I made. And I call it the projected sun. So a couple years ago, so this is an eclipse that I filmed without wearing glasses, just looked at it. The sky was a little hazy, which made it really easy to photograph. And this is me simulating the eclipse with a backlit paper towel and something eclipsing it. So in Michigan, this guy took a picture of the eclipse. Now the eclipse is like 80-90% eclipsed. You can't see it because it's just blowing out, but this is like 80-90% eclipse. But we saw this, like, what is this light that's showing how much the eclipse is? And what is this one? Well, this is a lens flare because as we move the camera, it's moving around. But this one is locked to the sun, right? Yeah. So it's not a lens flare. So we're trying to figure out what it is. So clearly a lens flare, not a lens flare. And this is where I said, you know what? Maybe this, jump forward a little bit. Maybe this is the source of the sun. And it's outside of our sky, outside of the firmament or within the firmament, however you want to word that. So I made this model. I got a paper towel, and behind it I have the source light shining on the towel. This is it. And I'm moving a bottle cap in front of it. And I'm making this eclipse that looks amazingly like the real eclipse, right? Yeah. No one has ever seen the moon, supposedly eclipsing the sun, approach the sun, eclipse the sun, or exit the sun. They only see this shape. No one's ever seen it. Like, if you think about it, if the moon fully eclipsed the sun, how come nobody can photograph the moon? The sun is out. We can zoom in on the moon. We should be able to see the moon. No one's ever seen the moon, right? And it should be no one, like when the moon is going in front of the sun during a solar eclipse, when it's fully eclipsed, you should be able to see the moon, especially because from the moon's point of view, it looks at the earth. There's a full earth. Like we see a full moon. Well, the Earth is shinier and 6 times bigger than the moon. It should be lighting up the moon at least 6 times the amount that the moon lights up the Earth. And no one with any camera from anywhere, any space station, nothing has ever shown the moon eclipsing the sun. So let's continue here. So so I redid the experiment with a thinner sky. So I used tissue paper. Here is the source light behind. I can see the projector. And here is the eclipse. Look, this is the source. This is what we see.
Yeah.
And compare that to the eclipse. This is the eclipse. This is the source.
Interesting. So it had the same effect. Yeah.
Same effect. Explains many, many things. Right?
Yes. Yeah.
You can find lots of my videos right here. DITRH. That's my YouTube channel. Everything's linked at flatearthdave.com. So what do you think about that?
Yeah, no, that's interesting. It's intriguing. And like I said, I want to do more research on it. I'm not just going to leave it alone. I'm still going to look further into it, and I will use your app as the resource for that. So
right.
Yeah, but I really appreciate you coming on and walking me through it, because there's a lot of information online and it could be a little overwhelming sometimes. So it's nice to be able to ask these things.
What I suggest people just watch the one video a day. Just one video a day. Like when you're having your breakfast, put down the freaking newspaper, turn off the freaking television. Oh, yeah. Right? That's mind control. They steer your mind with the news. 100%. North, east, west, south, news. And what's in the news? FEAR, false evidence appearing real. It's all mind control. Yes. But this is what happens. I say, watch this video. And the good thing is, after you're done with watching this video, the next video that pops up is not a Google suggestion. It's a Flat Earth app suggestion. Yes. So people end up watching 3, 4, 5, 10 videos. And then when they get through those, they're like, I'm going to hit the archive button. And the next thing they know, it's dinner time. Okay.
Yeah. You get sucked in. So you're warning me that I'm going to get sucked in.
You're going to get sucked in, but I want you to use your mind. I want you to actually think, because you have common sense, God-given common sense, and they want you to believe complete and total nonsense.
Yeah.
No, and they laugh at you. Look, we've got a new user.
And I will use common sense. Like, I definitely am one of those people that I do question everything. I do question the narrative. I don't trust what comes out of the government or the news. So I think that naturally makes me a candidate to want to explore this, and to be open to it.
Very good.
Yeah. So we will see. And I will keep you updated. I'll let you know. I'll let you know how it goes. But yeah, thank you so much for taking the time to chat with me, to explain things, show me the evidence you have. I really appreciate it. I thought it was going to be an hour. So thank you so much for taking that extra time. I so appreciate it. And it was so nice meeting you and knowing that you're an OG Hexican.
Anything for a fellow Hexican.
I appreciate that.
Is that sexist? Is there a better way to say that?
Fellow. Yeah. Some people get offended over
Hexicans don't get offended, and neither do flat earthers. Good, right? Yeah. Flat earthers and Hexicans are the same. They're passionate and a little bit crazy when it comes to anybody objecting to us. We get a little crazy. Now, I want you to notice. So when we're done, I have a team of government-run shills that are going to attack in your comment section. They're going to say, Dave's a grifter. Ask him about eclipses. Ask him, how he's out there to rip you off, steal your $3. That's what I'm here to do. Steal your $3.
The $3. Okay? Oh my God.
But look at their channels. 0 content, 0 subs, and they never offer a globe proof. Never. They never offer a globe proof. So watch out for them. They're going to show up.
Thank you for the warning, it's all, So they're going to send their attack dogs out on you. So I got it.
Yeah, there'll be a few. And what they'll do is they'll comment on other people's comments mostly. And they'll be like, Dave's a scammer, the AE map has been debunked, but they'll never tell you how or why or give it a globe proof. And then you just go look at their channel if you want to take the time and look at their channel. Empty troll channels.
You know what that reminds me of? That reminds me of whenever I try to post hex stuff on TikTok, I get the same exact response.
Yeah, they don't
Spam
want
right
they
this.
don't want good information out there.
No, no. So you're right. Yeah, so much crossover between the two. Yeah,
Yeah.
I'm seeing a lot of that happening. But yeah, so thank you again. It was so generous of you, and thank you everybody in the chat, and thank you to everybody who's watching the replay. Yeah, it was awesome spending these 2 hours with everybody here, and you all have a wonderful weekend, and you have a great weekend, Dave.
All right,
Thank you
thanks.
again. Bye.
All right, bye-bye.